I'm Ethan. I lead data and applied science inside IVS, Amazon IVS, also Twitch video. And I'll kind of get into how it's both things at once in a second. Before starting, a few disclaimers. First, we are practitioners, not a startup, so I'm not trying to sell anything. Really just talking about our story applying Gen AI here. We don't believe we're pushing the state of the art, but really just finding value in what's currently available off the shelf. And finally, there might be spicy takes, and those don't necessarily represent the views of my employer. So take it with a grain of salt. Okay, so let's get started. I'm going to start by playing a video. I want you to forgive me for the marketing language, but I think it's going to do a much better job of explaining what we are than I would. So.
Managing live video streams at scale that have end-to-end low latency and are ideal for user-generated content platforms, retail, education, and other interactive apps is complex. But with Amazon Interactive Video Service, you have a managed live streaming solution that provides low latency or even real-time video, allowing you to create engaging and interactive live experiences without video expertise. Use the same live video infrastructure that powers Twitch to build experiences to engage and connect with your viewers. Integrating Amazon IVS into mobile applications and websites using our SDKs is simple, and you only pay for what you use, with no minimum fees or upfront commitments. Amazon IVS low latency streaming can be under 3 seconds from host to viewer. Customize and enhance the viewing experience for low latency streams using the timed metadata APIs. And low latency streams can scale to thousands of channels and millions of viewers watching and interacting with the video. With Amazon IVS real-time streaming, you get live video with real-time latency that can be under 300 milliseconds from hosts to viewers. Viewers of real-time streams can be brought on stage to join and collaborate with hosts. And combining low latency or real-time live video with a stream chat feature provides a space to grow your communities. Build engaging, interactive viewer experiences with Amazon Interactive Video Service today.
Okay, I'm going to go ahead and turn off my sound now, too, because my group chat is blowing up for no apparent reason. But yeah, that was the most painful part of the talk. I just wanted to explain what we are and what we do. We spun out of Twitch Video, and now we are our own AWS service that offers the same infrastructure as a service. And yeah, we have lots of customers globally now that use that infrastructure for video. And I'll skip this slide because this was a backup in case the video didn't work. So my team inside that group is the data and applied science team. We are small but mighty, composed of both data and applied scientists. In person, we don't all look like convicts. That's just the internal Amazon profile pictures. But yeah, as you can tell, we're not a big team, but we support a pretty large org, which kind of plays into the impetus of why we wanted to push into automation. So specifically, what do we do? Well, as I mentioned, we cover both data and applied science. Under the data science category, we focus quite a lot on quality of service and quality of experience, and our ability to relate those two measures. For quality of service, we are looking at things like buffering per minute watched, latency, time to first frame, stream starvation. For quality of experience, we focus mostly on watch time as a proxy determination for if someone is having a good time watching video or not, if they keep watching. We also work on forecasting video traffic, especially around large live events. We want to know where people are going to be watching, at what resolution, etc. Recently, we've begun to dive more into real-time operations instead of focusing mostly on kind of look-back analytics. This is because we're pushing more into AWS, and we're having to take on more of that operational load. So we're also trying to automate around our real-time operations. Finally, we do normal product analytics in that we push out features, we want to measure adoption, that sort of thing, and quite a bit of data modeling, trying to make our massive data more efficient to query and get stuff out of. On the applied science side, we focus on bot detection. So a lot of the platforms we support, including Twitch, allow anonymous viewership, which means that you will be inundated with bots, and we are tasked with trying to figure out what is a bot or not. We do some work around traffic shaping, meaning we try to understand where traffic will be, especially ahead of live events, and push them over the network to optimize that traffic flow. We work on super resolution, so on-device upscaling of video. If you're in a network-challenged situation, we could send a lower rendition and then use your device to actually make it look better. We focus on video encoding, so this is just a base optimization problem. How do we compress the video quickly but efficiently to make the bit rate lower but quality still high? And then finally, we're looking now at video understanding, so really actually watching the video with a model, something to try to understand what's going on, both for recommendations, ad targeting, content moderation, that sort of thing. So that's what we do. What does our setup look like? So our data infrastructure probably looks pretty familiar to anyone who does first-party tracking using AWS stack. We have a public edge where all of our player and broadcast clients can send tracking events, as well as any internal service that wants to. We then do real-time validation before passing it on to Lambda that does some enrichment and anonymization of the data. Finally, it's all thrown into S3, into date partitioned Parquet files. It's probably all very familiar to data teams. In terms of volume, we consume about a few 100 billion events per day from across the stack. So I would say we're in this big data territory. And everything is schematized on top using the Glue catalog. On top of these, we also support real-time applications through Kinesis streams that can fork off after the enrichment step. And yeah, all in all, I think this infrastructure is fairly simple. It's horizontally scalable and works well, and actually is, I think, kind of common across the industry for people that use AWS. Best of all, it's internal to us, so we get a really good deal on it. We call it Berryessa, so if I use that term from here on, that's what I mean is our data lake. And this is a picture of Berryessa, the lake in the South Bay, that has a very famous, it's called the glory hole, that is in the middle of the lake. So in terms of tools on top of our data infrastructure, we use dbt to do data modeling, dbt core in particular. We use Hex as a BI tool, which is quite nice if you haven't tried it. It's a notebook-first BI tool, which we find to be very helpful. For operations, it's a bit more diverse right now, with teams choosing different tools based on their part of the stack. So we have OpenSearch, managed open source search, which is like an ELK-like stack. Grafana, which is, for us, supported by Apache Druid. And then, of course, CloudWatch, some teams choose to use. And then finally, we have an internal support tool, an operations tool called Carrot, which is, it's obviously in-house built, and carrots in general in Twitch, for whatever reason, is very important to the lore inside Twitch. For whatever reason, the name Carrot carries a lot of weight. So what's the problem? Everything seems fine. Well, first, our request to analyst ratio is pretty daunting. We're about like a 50-to-1 right now, which is, yeah, it's on the heavy side, I would say. And we need a way to become more self-service oriented. For the requests we are able to field, they often can break our focus. These are probably common problems. We get pinged on Slack at all hours of the day, even on vacation, and we get asked questions like this. It's not even a question, it's just a statement, and it's at 9 p.m., so I don't even know how to respond. The request space is essentially infinite. When we have problems, it's very difficult to do root cause analysis. They can come at any point in the stack. And yeah, SQL knowledge and appetite really varies wildly. we are at least like a very engineering-heavy org, so people have some desire for self-service as they can, but others won't touch it. So what do we do about this problem? Well, as like the title gave away, we're going to try to automate. We're going to try to use LLMs for analytics. Yeah, seems like this wave of automation is coming, so let's try to surf it. So what is the vision? The vision, I think we and like a lot of startups making these things put forward is an AI data scientist, which would mean in some ways like a self-driving analytical system. It needs to know about all of our data, all of our events, our cubes, etc. It needs to know how to operate on that data through querying, getting results, studying the results. And it needs to know what to do with the information once it has it, like alerts, dashboards, that sort of thing. All in all, it should act as like a proxy for us for these ad hoc requests that we're getting at 9 o'clock at night. And hopefully, in many cases, those requests don't have to come back to us. It should be conversational because requests are like this. Do we have data is not specific enough to give an answer. So it has to be a conversation where you go back to the stakeholder and ask like, okay, what data do you want? Like, what question are you trying to solve? And so whatever we make in terms of automation needs to be able to have a conversation with the stakeholder to actually get to the specific thing that they want answered. And finally, it needs to integrate into an existing tool. We already have too many tools for how big we are, and adding another one to the stack is always difficult. You need to learn a new process. So we want something that is where we are already working. Do we build it or buy it? And this is where maybe my takes get a bit spicy. So first, I think vibe coding now is a real thing. And if you haven't tried it yet, then I would highly encourage you to do that because it upskills, especially data analysts, data scientists who have analytical minds, but maybe not the engineering background, that you can really now, through vibe coding, make scripty things like bots or chatbots fairly straightforwardly. I think this trend is going to make it very hard for SaaS. At least like the bar to entry is now higher in this build versus buy debate because building is becoming much easier. It's also very fun if you haven't tried it because you can feel productive even if you're a manager. Like you can build stuff. It still requires some expertise. You got to coach it, but it's really like nothing before. Secondly, I think in general, when there's a big wave of automation coming, if AI data scientists are going to be real, it's much better to be the automator than the automatee in that situation. And so in some ways, there's a selfish desire, like, okay, let's try to build it ourselves. And finally, bike shedding is fun and good, which is a spicy take. But I don't know if you've tried like really getting excited about a project and throwing yourself into it. And of course, I say this a bit tongue-in-cheek, especially the latter part. But yeah, it actually, for us in this situation, ended up providing a lot of value to focus on something that wasn't necessarily our top priority. And I think it's fine as long as you keep in mind that one, you're kind of building an internal tool, and two, if you wanted to throw away everything, you should have the emotional maturity to be able to do that. So yeah, let's check out our bot. So first, what is it? Well, the IVS Data Bot is a raccoon-themed Slack bot that does a bunch of cool stuff for us. Raccoons are appropriate for this conference in Oakland because, I mean, I live in Oakland, and there's, in fact, a family of raccoons living between my house and my neighbor's house. So you'll see a lot of raccoons for the rest of this talk. So the first thing it does is report recommendation. Here you can see one of our product managers asking, do we have a dashboard for this thing? And it knows about our trusted dashboards that my team has made and will recommend them and specifically say like what this dashboard contains and what things you can filter by. Second, SQL generation. So it will generate queries for you based on a question. This is really the meat of the application, both in terms of use and complexity. Though honestly, likely secondary in value to the first thing of just telling someone where the right report is, because we've put a lot of effort into building nice reports, and finding them is still hard because there's too many, and search is difficult. Account lookup. So this is a pretty straightforward application where you just want to ask, like, who is this customer, or what is this customer's ID, or I have this ID, and what customer is it? And here I don't scroll all the way down because I don't think the customer IDs are public, but trust me, it gave the right answer, and this use case, it actually pretty much always gives the right answer. And finally is summarization. This is really the bread and butter of these models, so it actually works really well out of the box. Essentially, if you find yourself in a Slack channel where like there's been a thread and it says there's over 100 messages in this thread, and you're like, I'm not going to read all that, the model will read all that and summarize it for you. And this has been especially useful for us during incidents. If there's an incident, then there tends to be a lot of back and forth chatter, people expressing frustration and suffering, and the bot's able to summarize all that really well. So how does it work? I'm sure given the nature of this conference, everyone is saying, I know exactly how this works, and you'd probably be right, which is good. But let's go through it anyway. So here's the dump of our architecture. The entry point for users is Slack, of course, where you can @ the bot to start a thread. Slack.com then hits our API gateway with webhook events. We process the ones that mention the bot directly or are already in an active thread with the bot, and we drop the rest. The ones we do process are done through Python Lambda that defines all the bot behavior. So everything about this is really, the logic is in one Lambda function. The Lambda gets its data from a variety of sources depending on the task being performed. It connects back to Slack to read out both the history of the thread and the history of the channel when necessary. It also gets loads of data from that's being stored in S3, including schemas and tables and events, as well as other lookup tables for customers, for example. And stuff gets into S3 mostly through a managed Airflow cluster that we have doing ETL in that way. And Airflow is able to reach out to Berryessa and ask the Glue catalog or Redshift, what are the schemas with descriptions and types and everything. And then finally, of course, we use Amazon Bedrock for all the models. It's all private in the sense that like it's all within our private VPC, so nothing is really escaping in terms of customer data. Like everyone else, I'm sure we use like an agentic workflow, which is like a fun new term that to me more or less means just calling the model in a loop and carrying the context along with you. We first try to determine what task it is you're trying to solve, so there's a first pass there where we hit Bedrock. Once we have the task in hand, then we iterate, depending on the task, to form a final prompt, essentially. And once we have the final prompt, we think we'll successfully answer the user query. We hit the best model we have, typically, and then parse the response and send it back to Slack to the user. We do try to give some hints in the middle in case the response is going to take too long, just so the user doesn't think, like, is it broken, or am I just waiting? But sending it back to Slack is then important because the user is able to close the loop. About half the time, there's going to be a follow-up question, or the user will realize this isn't exactly what I want, I actually meant this. And so it's important to actually think of this whole loop. So that's the generic setup. Let's look at the individual tasks now. So first off, report recommendation. Somehow we need to let the model know where the trusted reports exist, what they contain, and what sort of questions they can answer. At first, this information was provided manually. So a data scientist on my team, Jingrong, who's here, did a bunch of like manual work describing our most important dashboards to be included into the prompt. But now she's found that instead we can feed that, we can dump big YAML files per project from Hex and feed that YAML file into an LLM to get a concise summary of what's in the project, and now we can use those. And it leads to a system where Airflow daily will grab these YAML files, hit the model, get the summaries, put the summaries on S3, and then those summaries are used within our active bot. The actual prompt looks like this. It's an introduction statement. Then we paste all the report summaries that we think could be relevant, and then finally the user's question at the end. So fairly straightforward. SQL generation, as I mentioned before, is really the meat, and there the prompt is a bit more complex. So first is an introduction, then we include all the schemas that we think would be relevant to the user's query. We have a bunch of example queries, which are essential for the performance of the bot. And again, Jingrong put a ton of work into writing those examples to teach it how to join, how to partition the data, how to write good CTEs, et cetera. And there's a section around definitions, special instructions, what we do as a business, what these acronyms mean, et cetera, how to form the output. Finally, we inject previous context, because obviously it's been a conversation, so you need a way to keep the bot up to speed, and then the user question itself. As I described before, everything is coming from the Glue catalog in terms of schema, and then everything else from S3. One potential source of improvement for us would be getting the examples in an automatic way. We don't do that today. So when we add new tables in, we're adding more examples in as well, manually. Account lookup is very straightforward. We give the bot a big table of our customers, their IDs and names, and then just ask it based on this account, and it's able to do lookup. I was somewhat surprised it worked directly out of the box, but it did. We provide some aliases for the customers, so it's a bit of a fuzzy search in that way, but yeah, this works really well. Summarization, again, is the bread and butter of these models. The first step is figuring out what range of dates the user might care about when they're asking, like, what happened here last week? Have you been on vacation? Or what's going on here if you're in like an incident that just happened an hour ago? So you have to figure out what dates of history you care about. Then we grab all the history from Slack, and we ask the bot to summarize. That's it. We do, sometimes the history gets too big and we have to recursively summarize, but that's pretty easy. We just chunk it up by thread, summarize each thread, then summarize the summaries. Yeah, probably that also just works. So in general, I think the mantra is try the stupid thing first, which is just ask the model to do it. Finally, RAG. Well, first let me address this raccoon. I consider generating slides images for the slides, but I think that's already passé. So I decided to go back to cute animals as the theme. And here, this raccoon clearly has more books than it can read at once, which to me inspires it needs to use RAG. So RAG, to me, is just an optimization for forming the prompt where you need to inject just the context you care about. We actually started and had the bot in production without RAG at all to begin with, because everything fit. But eventually we added enough tables that okay, we should try to RAG. The first RAG implementation I tried, I entirely vibe coded. I just asked it to use TF-IDF, and that worked sort of well. But then I decided I should go back to my own mantra and just try a model at first. And so that's what we do now. Is I first get very concise summaries of all the tables, or very concise summaries of all the reports, and then I shove it at a model and I say which are relevant. And then once it tells me which ones are relevant, I just grab those, and that's my RAG system. I think if even then that list got too big, I still wouldn't go to a vector database. I would just fan out. So break the number of reports into chunks, and then again, kind of recursively, which one of these are relevant, which ones of these are relevant, and then bring them together. So again, this mantra of just try the dumb thing first. Okay, so that's it. It's not too bad in terms of complexity. How well is it performing? So yeah, quite well, I would say. So we have evals for three of the tasks, including task selection itself, report recommendations, and SQL generation. Account lookup essentially never misses, so we didn't even bother putting an eval in place. For the first two, we have more or less exact answers. So creating the evaluation criteria was really straightforward. For those, we have an operating threshold of 95% on the task selection and 90% on report recommendations. And anytime we make changes, we just ensure that we are above target, in which we are today. For SQL generation, evaluation's a bit trickier. I do believe what we have today is good enough, but there's some. Anytime we add new tables, we need to add new evals, essentially. What we do to ensure that ensure that the appropriate tables are present whenever we get back a response from the bot in our evals. But as we add more tables, there become multiple ways to get the same right answer. And so essentially we define sets of tables, sets of keywords that need to be present in order to check that we're getting the right thing. We also ensure that explain on the Redshift passes. Explain is a very fast way to make sure that the query plan can be made. And we ensure that passes as a part of the eval. But we stop short of actually checking, like querying for the data and checking the result because our data is quite big. And that would make the test very slow. And possibly if it got it wrong, they would never finish. So checking the data output as a part of the eval was not going to work for us. So that's one way to look at how it performs. The other way is to look at actual usage. I just thought this raccoon was really cute. 25% of our org are active users, which is really good because that's 25% of questions that are no longer coming directly to the team but being answered by the bot. It's a few hundred messages a month that is actually answering questions for. So yeah, it's a big load off. And the most important metric, my last 2 vacations were uninterrupted, which was amazing. Yeah. So I think we're in a good spot. I think it could definitely be improved, but it is already today providing value. So let's take a moment to go through what we think we learned and like what we think future steps are. So first, data documentation is critical and is actually what the long pole of work was actually documenting all our tables and schemas and writing examples. And it's crucial for the quality of the bot. And I think this would be true no matter if you built it yourself or went with a vendor. It's really a garbage in, garbage out scenario. If just the column name is ambiguous, if a human can't figure it out, then the bot's not going to either. So this is critical. Second, I've said this multiple times now, but when in doubt, just try the stupid thing of hitting the model and asking. There are a multitude of ways to build these things, but the first thing you should try is using the model directly. It's today's brute force option, and in the world of optimization, brute force is always the first and last thing you should try. It's how we got to our RAG system and recursive summarization, and both those just work. Model selection is important, both for quality. From our experience, this latest generation of models, even one before, is like good enough for the hardest questions, provided all the context is present. But some things you can get away with an even cheaper model. And that's recommended just because the user experience is better if the latency is lower and like the bot is more responsive. But generally, I would advise first trying to make it work with the best model. It'll be slow, so following this mantra of make it good, make it work, make it good, make it fast. Long threads get confusing. So here, someone had been talking for a long time with the bot. It was generating responses. And eventually it lost the context. And it forgot that it was trying to answer a question, but instead thought it was trying to generate a dialogue between a human and a computer. And it started playing both parts, and the human started spamming the Bezos buy emoji. So this is what led us to realize we need to actually also recursively summarize our threads as we go, that it needs to fit inside a context window. Or even if it fits, you should make it concise or it'll get confused. You might not need a framework. So we built the whole thing, at least at first, under 1,000 lines of code in a Python Lambda, with no framework, just hitting these various services. This might be a spicy take here, I don't know. Yeah, since we were able to get a lot done without really relying on any framework. And that's partly because, yeah, this. Vibe coding is real. I'm a recent convert after this QCLI was released because I live in the terminal, so once it came to the terminal and Vim, I was like, oh, wow, this is actually working. There are a ton of these tools, and I'd really encourage any data scientist that is not necessarily an engineer by training to try it, because it's a real thing, and you can get a lot of value out of, especially building Python scripties, it's really good at. And then finally, an important part of that is don't fall in love with what you built, especially if you're building internally. Be willing to throw whatever you have in the dumpster if something better comes along. If someone offers it for cheaper or for less. If some startup wants to pitch me on why I should throw it in the dumpster, I'm more than willing. So finally, the future. Right now, the bot knows about our trusted cubes, which are our stamped tables, but I want to give it everything. I want to give it all the events as well, but we need to do that incrementally. We will add additional evaluations as we go. There's some new things that didn't exist when we first started. There's MCP, there's Bedrock knowledge bases. Maybe we should use those, but we have something that works today, so it's not clear that it's worth actually migrating to them. Semantic layer, I've been told by multiple people here that we should have a semantic layer because it'll make the job of the bot even easier. And it's probably one of those things that pays dividends even without the bot. And then finally, maybe we'll throw it all away if if something better comes along. So yeah, that's it.